Hello students, welcome to Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we are going to solve this problem 610. The problem says that determine the force in each member of the truss and state if the members are in tension or compression. P1 and P2 are given. So P1 is 6 kilonewton. So this P1 is 6 kilonewton and P2 is 9 kilonewton. So first of all, we need to consider this whole truss and we need to find the support reactions at point A and B. So at point A, we will have two reactions. This one will be, let's say, AY, and we will have one horizontal reaction. Let's say this is AX. And at point D, we will have only the vertical support, right? So this is DY. So now to find these reactions, if I apply the summation of forces along x-axis is equals to 0, if this is my positive x and y-axis is, so as we can see that there is only this ax support in the x direction, right? So this means that this ax is equal to 0. So this means that ax reaction is 0. So we need to remove it. Similarly, if we apply the summation of moment about point A equals to 0. So as we can see that this dy is producing the counterclockwise moment about that point A. So I will write dy, and the counterclockwise moment is positive, and the moment arm of this dy from that point A is 4 plus 4 plus 4, so it is 12. So I have to multiply it with 12. Then this P1 and P2, both of these are producing the clockwise moment. So the moment produced by P1 is, it is clockwise, so you have to put minus sign. P1 is 6 kilonewton and the moment arm is 4. The perpendicular distance of this P1 from that point A is 4 meters. Similarly, P2 minus 9 and the perpendicular distance of P2 from that point A is 8 meters, and this is equal to 0. And if I bring these two terms to the other side of equation, so they will become positive. So if we divide both sides of equation by 12, so we will get dy magnitude. So this is 6 into 4 plus 9 into 8 divided by 12. So dy comes out to be 8 kilonewton. Dy equals to 8 kilonewton. So this is 8 kilonewton. Now if we apply the summation of forces along y-axis is equals to 0. So AY is acting in the positive y, so I will write plus AY. P1 and P2 are acting in the downward direction, that is in the negative y, so we will subtract it. So minus 6 minus 9 and plus dy. Dy is acting in the positive y direction, so I will write 8, and this is equal to 0. So we can find it. So AY will be equal to this minus 6 minus 9, so this is minus 15, and minus 15 plus 8 is minus 7, so AY is 7 kilonewton. So now we know the support reactions. This AY is also 7 kilonewton. So now I will start with the joint D, since we will solve this by using the method of joints. So I will write joint But before going to consider the forces at joint D, first of all, I will find the length of this ED member and the length of this EC member, right? So for that, I will consider a triangle, this triangle, right? So the base of this triangle will be 4 plus half of this length, right? So this, since this whole truss is symmetrical about this line, so we can find this ED length by applying the Pythagoras theorem. So we can say that the length of ED member square will be equal to this square. Let's say that this point is x. So dx square. So dx square is 6 meter, and plus this height, and this height is 6 meters. So this is 6 square as well. So if we take the square root, then we will get the length of that ED. So this is 6 square plus 6 square. So this gives us 6 square root 2. So ED length is 6 square root 2 meters. Similarly, if we consider this ECX triangle, so we can find that EC length as well. So EC, again EC square will be equal to this CX length, which is 2 meters. So 2 square plus this 6 meters square, so this is 6 square. So 2 square is 4 plus 6 square is 36. So this gives us 2 square root 10. So this is 2 square root 10 meters. Now this will help in finding the components of this, the ED member force and this EC member force. Now if we start with that joint D, then here we will have this CD member force. So let's say that the force in this CD member is acting in this direction. Let's say this is that CD force, and we are assuming that this CD force is the tension force since it is acting away from the joint D, and let's say that this is DE member force. So this is DE. So I am eliminating, I am not going to write this FDE. So this DE will mean that it is the DE member force and CD will mean that it is the CD member force. So now if I apply the summation of forces along y equals to 0 for this joint D, but before that if I apply the summation of forces along y equals to 0 at joint D, so first we have to resolve this DE force into its components. So it will have two components. One component will be acting like this. This is the horizontal component. It will have one component which will be acting in this direction. Let me keep these forces here. So this is that joint D free body diagram, right? So this is joint D here. So here we have that theta, right? So again I have to draw that triangle. Let me have that triangle as well. So the summation of forces along y. So if this is that theta, so then this one is the sine component. So we can write that dE sine of theta component is acting in the negative y. This is our positive y direction. So we will write minus dE sine of theta plus this dy, which is 8 kilonewton. So this is equal to 0. If I bring this to the other side, so it will become minus 8. And we can find sine of theta by considering this large triangle. So from that, this is that x point. So from that we can write that sine of theta is perpendicular. So perpendicular length of this triangle is 6 by hypotenuse. So hypotenuse is ED, which is 6 square root 2. So 6 will cancel out, so it is 1 by square root 2. So sine of theta is 1 by square root 2, and minus sign will cancel out. So from this we can say that dE force is equal to 8 square root 2, and 8 square root 2 gives us 11.314. We can say that it is approximately 11.31. This is that dE kilonewton. And as we have assumed that this dE is acting towards that joint D, so this means that this is the compressive force. Similarly, if we apply the summation of forces along x equals to 0, so again we have this, this one is CD. So CD is acting in the negative x direction. This is our positive x, so we will write minus CD plus the cos component of dE, so that is dE. Now dE magnitude is known, so we can write that it is 8 square root 2 cos of theta, and this is equal to 0. So again cos of theta from this triangle is, we can write that cos of theta is base. So base of this large triangle, that red triangle, is 6, and hypotenuse is 6 square root 2. So this is again 1 by square root 2. So we will write that this is 1 divided by square root 2, and 2 will cancel out. So this means that CD is 8 kilonewton. So we will write that CD is equal to, this will be minus CD plus 8. So that will give us CD equals to 8 kilonewton, and CD is acting away from that joint D, so this means that it is the tension force. Now we will consider that joint C. I will write so at joint C we will have that CD force is the tension force, so it must act away from this joint C as well. So this is that CD force now which is acting away at joint C, since it's the tension force. Then let's say that BC member is in tension as well, and let's say that this EC member is also in tension, and this is that P2 which is acting vertically downward. So this is our joint C free body diagram. Here I will write that this is point C, this is CD, and CD is 8 kilonewton, and this is CE, this is not known, this is BC, and this is that 9 kilonewton P2. Now we need to resolve this EC or CE member force into its components. So if we want to resolve it, so we need to consider this angle alpha. So if we have this triangle, so this base is 2 and this is 6, and the EC length is 2 square root 10. So we can resolve the C into its components. It will have two components. It will have one component like this, and it will have one component like this. So this one is the cos component, this one is the sine component. Now if I apply the summation of forces along x equals to 0 at joint C, so this is the cos component which is acting in the summation of forces along y equals to 0. Let's see, if I apply the summation of forces along y equals to 0, so this is CE sine of alpha. So it is acting in the positive y, so I will write CE sine of alpha minus this 9 kilonewton, and this is equal to 0, and sine of alpha from this triangle is, we can write that sine of perpendicular is 6 and hypotenuse is 2 square root 10. So it will be 3 divided by square root 10. So sine of alpha 3 divided by square root 10, and if we bring this to the other side, so it will become positive. So CE member force will be 9 square root 10 divided by 3, or 9 square root 10 divided by 3. This gives us 3 square root 10, which is 9.486. So let me write that CE member force is 3 square root 10, or it is equal to 9.486 kilonewton. And since CE is acting away from that joint C, so it is the tension force. Now if we apply the summation of forces along x equals to 0, so again this CD is acting in the positive x, so I will write it is 8 kilonewton minus this cos component of CE, so CE is 3 square root 10 cos of alpha. So this is alpha, remember, right? So cos of alpha is, from this triangle, it is base divided by hypotenuse, so base is 2 and divided by hypotenuse. So this is 1 by square root 10. So cos of alpha is 1 by square root 10, and then BC, so minus BC, and this is equal to 0. If I bring this to the other side, so BC is equal to the summation of both of these terms, right? So this is 8 minus 3 square root 10 will cancel out, so it is 8 minus 3, right? So this is 8 minus 3, so this is 5. So BC is is 5 kilonewton, and since BC is acting away from that joint C as well, so it is the tension force as well. Now we are going to solve that joint B. So let me write that joint So at joint B, we will have that BC force. So BC force is the tension force, so it will be acting away as well. So this is that BC force. Its magnitude is 5 kilonewton. And then we will have this AB member force. And then we will have this BE. So this BE is making that same angle alpha. So now if we consider these forces, and if I resolve this BE member forces into its components, so it will have one component like this that is acting in the positive x, and it will have one component which will be acting vertically upward. So again, if we apply the summation of forces along y equals to 0 at joint B, so this is the sine component of BE, so I will write BE sine of alpha minus that P1, which is 6 kilonewton. So this is equal to 0, or we can say that BE sine of alpha is equal to 6, and sine of alpha is that 6 divided by square root 6 divided by 2 square root 10 if we consider this triangle now. So if I consider this triangle, this one, so from this triangle we can, again this height is 6 and this base will be 2, so we will get that 6 square root 10, and the length of EC and the length of BE member both are equal, right? Sine of alpha is 6 divided by 2 square root 10, so we can write that BE equals to 6 into 2 square root 10 divided by 6. So this gives us BE equals to 2 square root 10. So 2 square root 10, this is equal to 6.325. So BE is 6.325 kilonewton, and since BE is acting away from this joint B, so this means that this is the tension force. Similarly, if we apply the summation of forces along x equals to 0 at joint B, so this AB is acting in the negative x direction, so I will write minus AB plus the cos component of BE, so I will write BE, and BE is 2 square root 10 cos of alpha, and plus that 5 kilonewton force, that BC member force, so I will write plus 5, and this is equal to 0, and if I bring this AB to the other side, it will become positive, so we will have the equation like this, and cos of alpha is this thing. So cos of alpha is 1 divided by square root 10, so I will write 1 divided by square root 10 is cos alpha, and this will cancel out. So this is AB is 5 plus 7, so this is 5 plus 2, so this is 7 kilonewton. So AB is 7 kilonewton, and AB is again acting away from that joint B, so it is the tension force. So now ultimately we reach at joint A, so again we need to consider the forces at joint A as well. Now let me draw the free body diagram at joint A. So let's say this is that joint A, and at joint A the AB force will be acting away from that joint A, since the AB force is the tension force, so it will be acting like this. This is that AB force, which is 7 kilonewton. Similarly, AY will be acting vertically upward. This is that AY, and AY magnitude is, we have determined this, AY magnitude is 7 kilonewton, so I will write this is 7 kilonewton. And similarly we will have this AE member force, right? So this is AE, let's say it is compressive force. So again, if here this DE member is making theta, so it is also making that same theta, since the truss is symmetrical about that center line, right? So this is that theta. Now if we resolve this AE member into its member force into its components, so it will have one component like this, and it will have one component which will be acting vertically downward. So again, if I write that we are considering joint A, and if we apply the summation of forces along x equals to 0, this is our positive x direction. So this is the cos component, so we can write that AE cos of theta is acting in the negative x. I will write minus AE cos of theta and plus this 7 kilonewton force. So this is 7 and this is equal to 0, and I can bring this 7 force kilonewton into the other side of equation, and cos of theta is 6 divided by square root 2, or we can say that it is 1 divided by square root 2. So this is 1. So minus sign will cancel out, and we can say that AE member force is 7 square root 2, and 7 square root 2, this gives us 9.899. So 9.899 kilonewton. This is AE member force, and AE is acting towards the joint A, so this means that it is the compressive force. So we have determined the forces in each and every member of this given truss. I hope you people would have understood the method for solving such kind of problems. Kindly subscribe my channel for the solution of such more problems. Also like this video if it helps in your learning.